Mrs. Mills, this is Andrew Duncan, and this is my extreme weather project. It is on the Carrington event, which happened August 28th through September 2nd, 1859. This is my mobile that I have constructed. This is the sun. This is a coronal mass ejection. This is the solar energetic particles, and this is the solar flare, and this is the Earth. Let me just explain to you real quick what a coronal mass ejection is. Since the sun has so much energy, it creates arcs like this with its magnetic field and puts heat and energy through it. And when the magnetism shifts, these two parts connect, and it lets off energy like that and creates a new arc like this. And the shock wave creates solar energetic particles that are right here. But since the coronal mass ejection travels slower, I put the solar energetic particles in front of that since they travel a lot faster than the coronal mass ejection. And now I'm going to redo my research cards. This one says, where does this weather occur? Well, it occurs in space. This one says, what causes this type of weather to occur? A shift in magnetism in the sun. What are the characteristics of your weather event? First, when Carrington saw and predicted this happening, he saw white spots on the sun, which was the solar flare, because he could see the light from the solar flare coming, because that travels the fastest. It reaches the Earth in 3 or 4 minutes. And the electric currents on the Earth were messed up, because since the Earth's magnetic field goes like that, since the coronal mass ejection was had magnetism, when it went right here, it sucked in the magnetic field, and these two parts connected, and it created a shock wave and disrupted communications and electricity on Earth. And also from the solar flare, the sky was extremely bright, like abnormally bright. And afterwards, everything electrical related was completely damaged because of the shock wave. And what are 4 statistics of this event? This traveled. It went as fast as light goes, which I thought was extremely amazing. And this also traveled 92,960,000 miles in 3 minutes. And when the coronal mass ejection left the Earth, it was over 60 million degrees Kelvin, which is super hot. And it still remains today one of the largest solar storms in recorded history. How does this weather impact non-living things like land or water? It disturbed communications and electricity on the ground, because I told you about the shock wave. And they said even in the telegraphs, even when they disconnected the batteries, they could still send messages because of the magnetic charge in the air. How does this weather impact living things like humans or animals? If a human was out of Earth's atmosphere, like an astronaut, the solar energetic particles are super bad for the astronauts and are detrimental to his health and can also hurt the spacecraft. But if you're inside the Earth's atmosphere, you're protected. That's how God made it. Thank you for watching. Have a good. Oh yeah. The Earth I painted a plastic golf ball, blue and green, and this is the edge of a toothpick, which I thought looked pretty cool, like a light ray. And this, I didn't have anything that could like float in the air, so I used Legos since this looks kind of like particles. And the coronal mass ejection, I used a pipe cleaner. And for the sun, I bought a styrofoam ball at the art store and painted it yellow. And this is newspaper colored yellow with a wire in it, which represents the first part of the coronal mass ejection. And this is two metal hangers with some tape on it. Thank you.